everyone, my name is Bhujbar Khushi Diguje. I with my teammates Jayesh Bhujbar, Om Gaikwad and Darshan Amar. We are the student of the Sanjeevani College of Engineering from third year electrical engineering. Our topic is a model servo motor using transfer function simulates step and impulses responses. Study effect of the damping gain and the natural frequency. Basically, the main and the important component in this simulation is a servo motor. So at the very start, we are knowing about what is servo motor, what is exactly the function of servo motor. So the servo motor is a special type of motor which is used in precise control of the position where speed and movement. A servo motor works as a part of the closed loop. Wherever the servo motor is situated, is work as a closed loop. It means it is work constantly and continuously. Where any fault is occur, it can be repaired by itself. Then servo motor is very important motor in control system engineering, which gives a precise control, speed and movement. Then there is a need of the mathematical equation whenever the servo motor is used. The transfer function model make it easier and analyze the dynamic behavior of the servo motor without detailing the complex equation. Once the model is developed, then the tested using the step input signals. An important part of the study is analyzing how system parameter effect on the performance. There are the two main parameters, which is damping ratio and natural frequency.
So hello everyone. My name is Jayesh Arun Bhujbar. I am from Sanjeevani College of Engineering, Kopargaon, TY Electrical Branch, and we simulate. Our topic is model a servo motor using transfer function and study its step and impulse responses using and study its damping gain and natural frequency. So let us move forward. I will show you how our topics MATLAB simulation work. So let me tell you one thing. We take one pulse generator here, one step here, and 8 transfer functions here, and 3 multiplexers as well as 5 scopes here. So let us take all the parameters. One pulse generator, one step, eight transfer functions, three, four, five, six, seven, 8 transfer functions are there. So let us adjust transfer function. So let me tell you about transfer function. Transfer function is so all these are transfer function. So let me tell you what is transfer function. Transfer function is a mathematical way to represent any system. In that two systems are there, input system as well as output system. Input system consists of its voltage signal, and output system consists of our speed of motor as well as our position of the motor. So these 8 are our transfer functions: 1, 2, 3, 4, 5, 6, 7, 8. Then we will take 3 multiplexers here, which is mux. and 5 scopes. Let me tell you about multiplexer. Multiplexer is a device we use here. Multiplexer takes a multiple input from a source, and it gives a single output. It takes multiple input and gives a single output to our system. So let us take scopes. Scope. The main function of scope is to show the output waveforms. Five scopes are there. So let us join everything, guys. Guys, let me tell you about what is a servo motor. Servo motor is a special type of motor which is mainly identified its for precise control and its position. Instead of just like rotating like normal motor, servo motor, it's not a normal motor. It is mainly identified for its accurate angle, rotating angle as well as position. While talking about servo motor applications, it is widely used in control systems, industries, and automation and robotic sector. So let us join everything now. So guys, our joining process is completed now. So joining process is completed now. Then we will put the all the values here. First transfer function, we take numerator coefficient as a 1, denominator coefficient as a 1, 10 and 100. In second transfer function, we take parameters numerator coefficients like 1, numerator coefficient 1, denominator coefficient 1, 10, 100, as same as last. In third transfer function parameters, we take numerator coefficient as a 1, denominator coefficient as a 1, 4 and 100. Here numerator coefficient is 1 and denominator coefficient is 120 and 100. Fifth value, numerator coefficient we take 1 here and denominator coefficient 1, 10 and 100. We take a numerator coefficient as a 5 here and denominator coefficient as a 1, 10 and 100. Then we will take here numerator coefficient as a 1 and denominator coefficient as a 1, 5 and 25. And last transfer function, we take numerator coefficient as a 1 and denominator coefficient as a 1, 5, 115 and 225. Pulse generator, pulse type is time based, time t, use simulation time. We set amplitude time 1 here and period in seconds 10 and pulse width in frequency, pulse width in percentage of period is 5 and phase delay we set 0 here. We take step time as a 0 here and initial value we take 0 and our final value is 1. Sample time we take 0. Okay. So all the block diagram of our simulation is completed. So let me run this. Our MATLAB simulation is completely run. Let me show you one result. Our results are also shown. These results are all about damping, gain and natural frequency waveforms of our servo motor, how its effect on our system. These all output waveforms will explain by our group member Om Gaikwad. So let us conclude all this. So we model a servo motor using a transfer function and study its step and impulse responses, as well as we understood how damping, gain and natural frequency affect our system. So, affect our system performance. Thank you.
Hello everyone, my name is Om Gaikwad. In this presentation, I am representing the output waveform of a servo motor model using a transfer function. I know that you have a doubt or question, why 5 scope are added in this simulation? Because we will find out the 5 different types of waveform. First one is the step response, second is the impulse response, third is the effect of damping, fourth is the effect of gain. Fifth is the effect of natural frequency. Let us understand one by one of waveform. This is our first waveform. It is our step response. The step response shows a stable under-damped system. Output start from 0. You can see here output start from 0. Rise quickly after the step input. Right quickly absorb the step input. It goes above the final value, the first. It goes the final value of the first. This is oscillate slightly. The system is stable, has a fast response, small overshoot, and reaches steady state after a short setting time. Then we will go the second scope. Second scope is represented as the impulse response. This impulse response shows an under-damped stable system. Output rise suddenly to a high peak after impulse response. You can see here high input and then peak here. Then it swing below zero oscillation gradually decrease with time. The system is a stable oscillatory in nature and entry dies out with time after the impulse input. We will go for third scope. In this waveform, this is waveform of effect of damping. The graph shows the effect of damping on a system response. Yellow curve. This yellow curve are showing the low damping, large overshoot, and oscillation before settling. And blue curve. This blue curve are shows the high damping, smooth response with little overshoot, little no overshoot. Increased damping reduce oscillation and overshoot, making the system more stable and smooth. We can go for fourth scope. Fourth scope is a representative of the effect of gain. This graph shows the effect of gain on the system response. Blue curve. This blue curve are showing the higher gain gives faster rise time and higher output value with more overshoot. And yellow line is showing the lower gain gives slower response and lower steady state output. And all the things of the increase the gain improves response speed and output level, but too much gain can increase overshoot and oscillation. We can go for last of the scope. This scope is a representative of effect of natural frequency. This graph shows the effect of natural frequency on the system response. Yellow curve. These yellow curve are showing a higher natural frequency, gives faster response and large overshoot. And this blue curve are showing the lower natural frequency, gives lower response with small overshoot. And all the things are represent the increased natural frequency make the system respond faster, but it may increase overshoot and oscillation. So this is our output waveform. Thank you.
Conclusion. In the study, a servo has successfully modeled using a transfer function to analyze its dynamic behavior. The simulation of step and impulse response helps in understanding how the system reacts to different inputs. By varying the parameters such as the damping ratio and natural frequency, the effect of system stability and speed oscillation are observed. This analysis provided valuable insight into improving the system performance and designing a efficient control system. Overall, the study highlights the importance of the mathematical modeling and simulation in real-world automation application. Thus, a parameter has successfully modeled using a transform function which helps to understand how the system refers to different input on a simple mathematical way. Through the study, we clearly understand the importance of key parameters such as the damping ratio, natural frequency, and gain. The damping ratio effect of the stability and system low damping causes oscillation while the high damping makes the system response and gain control systems strength and the output by property adjustable this parameter. We can achieve a balanced performance with good speed and stability. We also learned the servo motor have important features such as high accuracy, fast response and feedback-based closed-loop control and system, which allows the passes control position, speed and torque. Because of these features, servo motor are widely used in real-life applications like robots, camera, industry automation. Camera tracking system with position and industrial automation. Overall, the study shows that the understand system parameter and proper tracking is very important for decisioning efficient, stable, and high performance control system. In conclusion, reference: we have taken information from different research papers at journal related to servo motor control system. I had the four references. All these references help to understand the theory, modeling and performance analysis of survey matter. Thank you.